Hey guys, Eddie here. I wanted to do a video today kind of showcasing some of the advantages of using threading in VB.net. My current project, I am working for a client. I've got some Visio challenges. I'm trying to manipulate a bunch of objects. And, I could go straight through the objects. There's about 8,000 of them. And I can cycle through and make the changes, but it's very slow. So now if I use threading, I can kind of do a multiple objects seemingly at once. I can have different things done to different objects seemingly at the same time. I say seemingly because I'm not using parallel processing, although you can do that in .NET. I'm going to be using threading, which essentially it can use multiple cores, but I think it's more just of a breaking up the processor time as opposed to actually dedicating a task to a separate core. So we're going to start with that. Now I don't have Visio installed, so we can't show this example in Visio, but we'll do something in Excel. I'll show an example of filling in a matrix in Excel, and we'll time how long it takes to do in a linear fashion. And then we'll use threading, and we'll break it up and see how much of a time advantage we get when we start to thread things. All right, so we're going to build this project in VB.net. So I'm going to launch Visual Studio here. We'll create a new project. All right, we're going to create a VB.net form. Here are Windows Form Apps. We'll call this Excel threading example. And Visual Studio 2019 will go out and create the project for us. All right, we got our form. All right, so one of the first things we want to do is add a button to the form. So we'll go over to our toolbox, grab a button, drag it out. Just keep in mind, normally I would, properly name the button and, give it a proper name here, and I would give it proper text. We'll give it proper text, but we won't rename it from button one. So we'll just say, here we'll just say linear matrix. And what this button should do is it should launch Excel, and it should fill out a matrix, maybe like a 50 by 50 or 100 by 100 matrix just of data. And we'll time it. We'll see how long it takes. And then we'll build another button where we use threading. All right, so what we're going to do is go into the button, and we are going to create an instance of Excel. We're not going to do it here, though. We're going to create a module for that. We could also create a class, and we could create a shared class so that we don't have to instance it. But we'll just create a module. It's easier this way. So we're going to add a new item, module, and we'll call it Excel. All right, so we got our public Excel module. And so one of the first things we should want to do is launch Excel. So we'll say here public sub launch. And this is where we're going to launch Excel. And we could even maybe make this into a function so that it returns Excel, because we'll have to call Excel in a few instances. And so, we might just want to create an instance to it. So maybe we'll create this as a function, and then we'll return the Excel object. And we're going to create our reference to Excel right now so that we get a real type, not just the generic object type. So we'll go to project, go to add reference, we'll look for Excel. All right, and we'll go with 15. It's the latest and greatest that I've got installed. Say OK. And typically when I start writing my functions, I like to just have it return something immediately, even though that's likely not what it's going to return. In Visual Studio, I've also noticed that in Visual Studio 2019, it wants you to start naming your methods with capitals. So I don't know where that started. It might have started some time ago, but it's not an error, but it's it's a recommendation that comes up when you rest your cursor over the little three dots that show up under your method. So I've been getting into the habit of doing that. So it's a nice little suggestion from Microsoft that I've been following. All right, so we're going to launch Excel with this function. And so we'll create an Excel object. So we'll just call it object Excel. Since our module is already called Excel, we don't want to call it the same thing. And we are going to use the Microsoft Office Interop Excel application method. Okay, and we could even just have this launch instantly, since we know that we're gonna, just set it and launch it and then return the launch. So something like this would work, and we could say return OXL. Could also, you can also do, instead of return, you could do launch equals OXL, but then remember that the execution continues on. Return it will stop, and then naming your function, it will still continue on afterwards. So in the above instance, it's probably better to use return. Okay. So we will get our newly instanced Excel application. And, we could test this right away. I'm a big fan of immediately testing things as they happen. The .NET environment and VB, I mean, all of the Microsoft products are super easy to debug and get through. So, it's really quick and easy just to scaffold something and just see the results immediately. All right, so we'll launch it, get our button, we'll click it. All right, so it did launch Excel, but I just remembered we did not set the visible properties of Excel. So we now have probably a ghost version of Excel running in the background, and what I forgot to do was set the visible properties. So we'll say, Excel visible is true. Now we should see Excel when we click on that button. I do that all the time. So there we go. All right, so now we have Excel, we have the frame of Excel, but we don't have a workbook. So that'll be the next thing that we want to add. So we can do something similar. I like to do like a cascade of functions when I build this out, so that one kind of calls the other, which calls the other. But like with the workbook and the sheet and the range, we don't have to cascade all of that, although it is a nice feature because then you can reuse those objects as you need to. Other thing we want to do is we don't want to return object, we're going to return the application. So we know we're returning the Excel application. All right, so we'll just start our subroutine. We'll say public sub create matrix, and this is where we'll create the matrix of data that we're going to post and then keep track of. So we need to create a workbook. So one of the first things we're going to do here is say dim wb as, and then we're going to grab the workbook object from this Excel namespace. So we'll create workbook, and we want to set that workbook equal to an instance of launch, and we want to basically add a workbook. So we'll say workbooks.add, and we don't want to add a template. We could, though. It's one of the parameters. It's an optional parameter. All right, so now we should get a workbook when we launch our code. We have to just change this because now our point of entry is now, instead of launch, it's create matrix. And we're relying on launch to create the instance of Excel that we want. All right, so we'll start this up. Click on linear matrix. We should get Excel with a workbook now. Perfect. All right, so far so good. Now the next thing we want to do is create an instance to our sheet object. So Same logic. I mean, the geniuses at Microsoft made this super easy so that anybody can do this. And so instead of the workbook object, we want the worksheet object. And we'll set that instance to the first sheet that is native when you create a new workbook. So we'll just say sheet equals the instance of the workbook that we just grabbed. And we'll say sheets 1. We always know there's going to be a sheet, at least one sheet in a workbook object. So that's pretty safe from a programming perspective. And we don't have to run this because it's just setting a reference to that sheet. We're not creating anything, so there's really nothing to see. The next thing that we want to create is, we could create a range object here, but we really don't need to. What we really want to do is just start building out the matrix so that we can time how long this thing takes. So we'll just basically create placeholders for the row and the column. So we'll just say row is long and the column as long. And we'll just create a loop here. So for row equals, let's say row 1 to 50. And I'll be honest, guys, what I'm about to do, I absolutely hate. I see this all the time when I inherit projects. It's, in my opinion, like the worst, worst programming practice ever. But what you'll see, and I'm going to do it right now, so forgive me, but the people will tend to do this. They'll just start nesting, and then if there was more, they'd continue, keep nesting, and that's just bad programming practice. The correct way to do it would be create another function or create another sub. So say private sub calls, and then in here we could say for call equals 1 to 50, and we could do what we want to do in here. So do work here, and all we need to pass in is the row, because that's the only thing we need from the top. I've already done it. I might as well just use this. But yeah, so don't embed for loops. I mean, don't embed anything. Just do it the proper way. Create another subroutine or another function, and just pass your parameters off to it. So here we're just going to say call. We'll call calls, and we're going to pass in the row. Okay, that's a much better way to do it. Now we probably will need to pass our sheet object. So we're going to have to add a parameter for sheet as here. And we pass our sheet object. And then we can build out a matrix of data. So we could say sheet, cells, and we can use the range object or cells. Cells is easier in this instance because we can just say the row and the column. And we can say the value is equal to, let's say, row, and column. Okay, and so now this should fill in a matrix for us when we execute this. And as you can see, this code looks much cleaner than when you start embedding stuff. So, if I had to embed and add logic here further, build out another function, and don't just add it to the same module. Add it to a module that makes sense. All right, so we're not using this routine anymore up here, so we can get rid of it, or this variable. So we are going to execute this, and we should see some data. All right, there we go. So it's filling out a 50 by 50 matrix. It's showing us the row and column, and it's probably done. And there we go, 50 by 50. All right, so sweet. So we now want to see how long that takes. So we have to build in a timer. So we'll put in our timer. And we basically want to wrap that timer out here because we want to see when this is done. If we put it down here, it would report on after every column, but we just want to see when everything is done. So, we'll say our start as date time, and end time. We can't use end because end is a system variable like end sub. So we'll say end time as date time. And then we'll set our start timer equal to now. It's you can use that in VBA too. Not sure what other Office applications you can use now, but now it should be a VB.NET function. And we want to report our end time as now. And then we'll just put up a message box so that we get to see the time. And we will basically take the end time, and there's some, in .NET it's so much easier to work with strings and do string manipulation than it is in VBA. Not that it's hard in VBA, but it's definitely a lot easier in .NET. All right, so we're going to subtract out the time of start, and then, because this is not in a format that we can read, we have to push it to a string, and that's pretty easy. In VBA, you'd have to do a cast to a string, so a CSTR commands to see something that kind of looked in a decent format. All right, so we'll run this again, and we should see time pop up once it's done running. And nothing popped up, so that's not good. Let's see what happened. Oh, there it is. Okay, so it says it took 11 seconds, so close to 12 seconds. All right, so we'll run that again just so that we can just do a little time comparison. And the other thing that we want to take into account is that we're also timing the time it takes to launch Excel, which is probably the most time. So it's not necessarily an apples to apples comparison. If it took, 10 seconds to launch Excel and that's consistent, we really wouldn't have a good estimate on our comparison of linear versus threading. So, just something to keep in mind. But, for our test, we should see, some benefits. All right, so we'll launch it again. It's running really slow. So it's doing 2,500 cells, 50 by 50. And we should see the time. And there it is. So in the same ballpark, 11 and a half seconds about. All right, so now we can close Excel. We'll close our app. So we know it takes about 11 seconds to do 2,500 rows or a 2,500 cell matrix in a linear format. So let's think about doing this in a threaded format. So threading allows you to kind of get different workers to do different tasks. So let's say we have one thread that handles the even columns, and we have another thread that handles the odd columns. So we can create a new routine here. So we'll call this public sub threading test. Oops, threading test, not text. And we are going to use a lot of the same components that we used up here. And, so we're lucky we don't have to rebuild the launch because the launch is a generic function. We can just use that. So we'll copy this because we'll probably use this. And then we'll just create different threads on the range object. We'll create like an odd and an even thread. So again, I hate copying code. I mean, the minute you're copying code, you should be thinking, well, maybe I should just write a function that handles that. And we were going to do that with like the workbook and stuff, but I decided against it. But if I really wanted to do some code refactoring, I might refactor that code. All right, so this is going to set us up with our workbook. It's going to set us up with our sheet object, so we're in a good position now. So now what we want to do is we want to create the matrix, but we want to create it in a threaded environment. So we want to create two different threads. We will need the timer, so we'll leave those there. But our threads we'll call odd and even. So we'll say we're going to create an odd thread as threading dot thread, and we're going to create an even thread as threading dot thread. Okay, so now we get the green line when you haven't used those variables yet, and so that's a nice feature in .NET. You can not only see, but VB.NET reports to you in a certain site. I think it's in the error list. It might show you. Yeah, there we go. Yep. So that's nice because, it just basically will allow you to clear out variables you're not using, or it reminds you that you have to set those variables, which is super useful because I have the habit of not setting my variables first. I go out and I build my functions, and then I work backwards, and so that's nice. All right, so we have to create a handler basically that's going to be called to launch these basically the thing that's going to fill the matrix, and we're going to create just one, which we handled by both. They'll just run in separate processes or separate threads. All right, so we're going to create we don't need it to be public. Well, it doesn't matter. So we'll say public create thread matrix, and we will pass in a range object, and you'll see why in a second. And so range object is the same namespace up here, except instead of worksheet, it's range. Okay. And we want that to be a sub, not a. Okay. There we go. All right, so what we're going to tell this thing to do is to basically start at the current range and just handle the even or odd column based on whatever your starting point is. So we'll say dim col as long. Row is that. So similar to what we had in our function up here. And we're going to do essentially the same thing, except we're going to split the load up so that its starting point is inherent when we call it, but it'll skip every column. So what we can do is we could say for row equals range.column. So if we start in column 1, it'll go to column 50, and it'll step every 2. And then for col, and again, I don't recommend doing this way, but I'm just doing this for speed. Oops, I did that backwards. I want to do col. And then we'll say for, oops, sorry guys, fat fingers. For row equals, or for row equals, and then we'll just do every row. And we could start to experiment and create even more threads. We can create 4 threads where one handles, odd columns and odd rows. One handles odd columns and even rows. One handles even columns and even rows, and one handles even columns and odd rows. So, we can really go crazy with this, but let's see what our, benefit and speed comes out to be first. So we'll just start with this simple one. So we'll do 1 to 50, and we're going to go right through that. And we're going to use our, I'm going to do this the easy way. So I want a reference to the sheet. I can do this in a quick and dirty way, but I'll do this in a way that kind of helps people out, which is I'll set a reference to the sheet object. And even though we didn't inherently pass in the sheet object, and I don't want to add parameters here because we're going to use this as I think it's called a delegate. I could be wrong. It's the address of operator, but you'd have to pass in parameters. So we don't want to do that. So we'll just say sheet equals range.parent, and that will inherently give us the sheet. Again, the geniuses at Microsoft make this super simple to program in. Parent of a range object is a sheet, parent of a sheet object is a workbook, parent of a workbook object is the application. Super simple. So it's all inherent. So I could have done, range.parent.cells, but I'm don't want to confuse anybody. So we'll do sheet.cells, and then we'll say, and so cells is the range object. You can use cells or range interchangeably. And we want to do row col And then we want to say the value, and then we'll do the same thing as we did up above. We'll say row and row, column and column. Okay. All right. So now what we want to do is we have to create our hook for the threads. And this is pretty simple. Again, geniuses at Microsoft have made this super simple. So we have our odd and our even threads, and now we want to launch them. So we just basically say, hey, let's create a new instance of our thread. So new threading.thread, and it already knows what I'm going for. It's super smart. And we're going to say address of, and then we want that create thread matrix. That's what's going to be called. And then we can say start it. Oops. So we'll say start it, and we're going to pass in our, so we're going to pass in cell A1. So that's that will be our odd columns. And then we do the same thing for evens. Same thing. Create thread matrix. And then we'll start our even thread. And we'll start that in B1 because we're doing by columns. And again, we can take this to the next level and get super crazy with it. But let's take a look at the speed. So now let's just run it first, even though we know we don't have a timer on it yet. But let's just make sure it works. So if we click, I want to save it and start it. Oh, we have to add a button. I totally forgot to add a button for our thread. That's our linear one. We'll create a button for the other one. So we'll create a button here, and we'll just rename this one threads, and then we'll create our hook to it, which is excel.threading test. Okay. Save it. We'll run it. And now let's see what results we get when we hit threads. Okay, there we go. So it's running, but we don't have a timer on it, so we don't know when it's done. There's not going to be any indication. We could look back in our immediate window output if we had like done a console write line, but we didn't add any of that yet. So, but we'll take a look at the spreadsheet, and there we go. We got our 50 by 50 matrix. Okay, great. So now let's add a timer. And we're going to see a real interesting result on the timer. Those of you who don't know threading might say, okay, well, you know, we probably will cut our time in half. That's actually the wrong answer. It's interesting how threading works, very similar to like an asynchronous call. You know, the processor will just keep running. So the threads are running, they're doing their thing, but your code will continue to run. So, you know, we should get an abnormally low time with our, when we set our timer. So all we have to set here is our end time, and then we just report on it. So we're going to show I just went blank there, end time dot subtract. We want to take out the start, and then toString, and that should show us how long it takes. But like I said, it's probably not going to be accurate because odd and even are going to come to run, I don't want to say in the background, but yeah, they're running in the background. End time and the message box will execute while these are still executing in the background. So we'll get our results, but we'll get an inaccurate time. And then I'll show you guys how to remedy that. So we'll click start, and we'll click threads. And there we go. So you see it says that it only took 1.6 seconds to finish, but we saw that it took longer. So that's because the threading is continuing. So what we need to do is we need to tell it to stop when it's finished with the threads. So we want these threads to finish first. So it's pretty simple. You just use a join method on the thread. So we're saying, hey, don't continue on with the code until you've finished with the odd thread and the even thread. And I think there might, I forget, I know with asynchronous calls, there's a wait all. I don't know if there's like a thread dot wait all. I'll have to research that. Anyway, so we can run this now, we should get a more accurate time on how long it takes to do our threading. So we'll run our threads. We should see hopefully about half the time. It's not always linear, but with a small example like this, it typically is. And there it is. So it's not quite half. It's a little bit more than half, and that's kind of what you expect because there is some management of handling the threads. And so we still have a nice increase in time. So we dropped by 40%. We processed 40% quicker by running threads. And so, that was 6 seconds, and now we can still run this right from our application. And this took about 11 seconds last time. It's probably going to be right in the ballpark again. And yep, there it is, close to 12 seconds that time. And we'll run threading again just to do another comparison. And you can see just by watching the screen, it's a lot quicker. So that one's 7 seconds, so it took a little bit longer, but still we're getting some nice gains. We're getting at least 30 to 40% gains. So again, I'm trying to accomplish this threading feature in Visio, which is really kicking my ass. But you can use it. It's very useful, and hope this example was useful to everyone.